Honors Algebra 2, Chapter 4 and 5. This is the Part B, graphing parabolas, quadratic equations, and we're going to look at vertex form and intercept form in this lesson. So vertex form, we've seen this form before in absolute values. So we're going to bring back our h and our k value. The difference is, instead of being absolute values, we're going to have the quantities squared. The vertex in this is hk, similar to how we had the vertex of the absolute value v. The axis of symmetry has not changed from yesterday. It's going to be x equals the x value, which ends up being h in this problem. And then our a value is still found. Our a value still describes a value here. As far as us moving left and right, we go up and down our a value. Sometimes I call that my awesome a value. Awesome a value. So identify the vertex in the line of symmetry. So here the vertex is going to be, it's the opposite of the number you see for our x value. So h is opposite of negative 3, so it's positive 3, comma, then the actual number including the sign for k. So 3, negative 5 is the vertex. The axis of symmetry is going to be x equals 3, the vertical line through that point. Here the vertex is going to be 4, 2. Axis of symmetry, x equals 4. The last one here, we have the vertex being negative 6, negative 2. And then the axis of symmetry is going to be x equals negative 6. So the vertex form makes things easier to graph. Similar to yesterday, we still want to find the vertex, and we still want to use symmetry to plot the points. And then if you want to use a table, you can do that. A lot of these, though, we can just quickly get the points. So vertex here is going to be 1, 3. Axis of symmetry is going to be x equals 1. If we plot 1, 3, we have this point. The a value is still the awesome a value. So from here, if I go right 1, and then go up 1, 2, because that's my a value. If I go left 1, I'm going to go up 2. You can find that by plugging in like a 0 for x, so still calculate it. You're still going to get 5 for that value. Now, if we want another point, and you plug in like 3 or negative 1, let's put in 3. 3 minus 1 is 2. 2 squared 4. 4 times 2 is 8. 8 plus 3 would be 11. If I plug in the point 3, I get 11. That's another point. So if you just off the graph, give me an idea. I'm using symmetry on plot more points. They flying around me. So then we connect these points the best we can. So there's a parabola opening up. So we can continue that here. Our vertex, negative 5, 2. Axis of symmetry is x equals negative 5. We'll plot that point, negative 5, negative 2. From there, if I go right 1, I'm going to go down 1 because my a value is actually opening down. I can punch in a negative 3 for x to calculate another point there. You can punch in negative 2, negative 1, even 0 to see how it's changing. 0 is probably going to fall off the graph. Then just plug in negative 2. So negative 2 would be 3, 3 squared, 9. Negative 9 plus 2 would be negative 7. So plug in negative 2 and 9 are negative 7. So this is 1, 2, 3 x values right of the vertex with negative 7. We have 3 x values left of the vertex that would also be at negative 7. So we can use x values further away to get a better shape of the parabola. So there's a little sketch. So once you understand the form, you're not really making the full table. You're pulling the points out of the equation. The same thing can happen with intercept form, another form. Here you can see how it's the two binomials being multiplied together. If we multiply these together, we get the quadratic. Right now it's broken up. These two values, we're going to talk a lot about that in the coming weeks. These are factors, they're solutions, roots, zeros, but we can find all those values from them quickly. But the x-intercepts are the spots P and Q. So if you set each parenthesis equal to 0, which is part of solving we'll get to here as well, you'll solve for that. So if I had like x minus p equals 0, I add p to both sides, I find x equals p is a point I need to plot. So x value of the vertex is the midpoint of P and Q. So if I find the midpoint of P and Q, I'm finding the vertex. So a couple examples here for these two zeros. If we find the x-intercepts, they would be 2, 0 and negative 4, 0. The vertex is the midpoint between those. So to find the x value of that vertex, I can add together and then divide by 2. So negative 2 over 2 would be negative 1. So then I have to plug in this negative 1 to solve for the x. So negative 1 minus 2 is negative 3. Negative 1 plus 4 is 3. So negative 3 and 3 is negative 9. Here our x-intercepts are 1, 0 and negative 3, 0. Our vertex is the midpoint. So again, if you want to average them, add. So we have negative 2 over 2. Negative 1 happens to be the same. So you have a negative 1 minus 1 is negative 2. Negative 2 times negative 2 is 4. 4 times 2 would be 8. So negative 1, 8 is the actual vertex. That's how you can pull some information away from the intercept form. So if we use that same knowledge to help us sketch it, our x-intercepts here is 1, 0 and 7, 0. Those are two different points. Then our vertex is the midpoint there. You can also figure out what is the middle of 1 and 7. So that's a difference of 6. If I add half of that, 3 to 1, I end up at 4. So the vertex is going to be 4, comma. And I plug 4 in, getting 3 times 3, negative 3. So negative 9, half of negative 9, positive 9 halves, or 4 and a half. So I plot that 4, 4 and a half up. Not pretty, but it's okay. And I can also plot the x-intercepts, so 1, 0, 7, 0. So also another reason why it's easy to graph these is because in these 3 points I can get an idea of the shape of that parabola just from those 3 points. They're spread out pretty well for this graph. So we can put these equations into vertex form just by simplifying. So it's a good review of OI or FOIL. So that would be x squared plus 4x minus 5. And you should become pretty quick at that. Then distribute the negative 3. So we have that result. Similarly, we have here, if we want to expand that, be careful. So then we get x squared minus 4x plus 4. Distribute the 2. And then we can combine like terms. That's a quick way of putting it into vertex form, or into standard form from vertex form. Last problem here, similar to yesterday, we can have an inequality. We still have the vertex 2, 7. Axis of symmetry is x equals 2. We can also use an awesome a value, 2, 7. I go right 1, we go down 3. Left 1, down 3. Plug in 0. So we get 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 plus 7 is negative 5. So then we have this shape. And when we sketch this, we're doing a dotted line because it's not or equal to. It's just less than. If I test a point, now here it doesn't appear to be going through 0, 0, and I can know it's going through the point down here at 0, negative 5, so I know 0, 0 is outside of the parabola. So I plug in 0, 0, I'm getting negative 2 squared 4, 4 times negative 3, negative 12 plus 7 is negative 5. So we have 0 is less than negative 5, which is false. And that point's not true, so the point's inside would be true. So that is it for graphing in intercept form and vertex form. Have a good night.